Hi everyone, this is your math guru. In this video, I'm going to explain all the standard formula for functions. That is, your parabola, your straight line, your exponential graph, and your parabola. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. Starting with the parabola, there are three forms of writing the equation of a parabola. I'm going to start with the standard form, which states that your y equals ax squared plus bx plus c. That's the standard form. The second form is your y equals a into bracket x minus p all squared plus q. And this is referred to as the vertex form. Now, note that for your standard form and your vertex form, you can change from standard to vertex using the method of completing the square. Now, to explain what each variable means, your p is referred to as the x values of your turning point. I'm going to tag the turning point as your TP, that's the acronym I'm going to use, while the PQ values, the P is for x values, the Q is your y values of the turning point. So therefore, if for example, you're asked to find the coordinate of your turning point, that's your TP, from the equation given, that is if it's given in the vertex form, or if it's in the standard form, you can convert to the vertex form by completing the square. Then your turning point coordinate, that's your x, y, will be your negative p and q. So therefore, if you're given values in p and q, you only need to negate your p values and leave your q values as it is. That will give the coordinates of the turning point. Also, the A means or determines the shape of the graph. For example, if the value of your A is greater than 0, then you're going to have a graph in this format, or I can call it the smiley face. And likewise, if the value of your A is less than 0, then you're going to have the opposite, or the sad face. Note that if I have the form y equals ax squared plus bx plus c, then I can have my x-intercept formula that states that y equals a into bracket x minus r1 multiplying x minus r2. I can get that by factorizing y equals ax squared plus bx plus c. Therefore, I'm going to tag this format my x-intercept formula. In this format, my R1 and my R2 are my x-intercept. Note that x-intercept, the value of my y is 0. And from here, I can find my axis of symmetry, which is equal to my coordinate x will be minus b divided by 2a, and the coordinate of y equals minus delta over 4a. Note that my delta equals b squared minus 4ac. You get the value of a, b, and c from your formula. That's your a, your b, and your constant c. Let's look at your straight line graph. For my straight line, I have the first formula, that's my standard form. That is, I have my ax plus bx. Oh, sorry, I'm going to change that. I have my ax plus by equals to c. That is my standard form. The second format is the slope-intercept form that states that y equals mx plus c. That is my slope-intercept form. And the third format, that's my point slope form. That is, I have my y minus y1 equals a gradient m in bracket x minus x1. I'll take out my point slope form. For each one of these, my m as given or as shown in my slope intercept form and point slope form, I have my m is equal to the gradient or the slope, and the formula is your change in y over your change in x, which is equal to y2 minus y1 divided by x2 minus x1, while my c is my y-intercept. The third function we're going to look at is our exponential graph. For my exponential function, the formula is y equals a multiplied by, the dot means multiplication, b to the power of x plus my q. In this case, my b determines the shape of the graph, such that if the value of my b is greater than 1, then I have an increasing function and the graph goes thus. Then I have an exponential growth. I'm going to tag that my increasing. That is, the graph is increasing, while if the value of b is less than 1, then you have a good guess that that will be decreasing as shown. And thus, there will be an exponential decay. Note that the value of q, as shown, shifts the graph vertically upwards or downwards. So what happens is, if the value of q is greater than 0 or positive, it's going to shift the graph upwards. So for upward shift, I have q greater than 0. And for downward shift, I have q less than 0. Also, we have a horizontal asymptote, that is the line in which the graph can never cross. And for horizontal asymptotes, you have y equals to q. The a in the graph determines or affects the steepness of the graph. And also, note that for the exponential decay, you have O is less than b less than 1. Let's look at the last but not the least function, that is the hyperbola. For hyperbola, the formula is y equals a divided by x plus p plus q, whereby note that x minus p cannot be equal to 0. We have two asymptotes for our hyperbola. We have the horizontal asymptote and the vertical asymptote. For horizontal asymptote, we have y equals to the value of q, while for a vertical asymptote, we have x equals to the value of negative p. Note that our a, or the value of a, will determine the position of the graph, such that if I have the value of a greater than 0, then we're going to have a graph position in the positive quadrant. That is, we have the value positive in the first and the third quadrant, while if we have the value of a less than 0 or negative, then a graph will be positioned in the second and in the fourth quadrant, as shown. Thanks for watching. Bye.